All right, I'm going to do a video going over the factoring quiz that you all took. All right, so let me go ahead and have you take a look at the factoring quiz. I'm going to go ahead and work on both of these. All right, I think I'm just going to do it in a whiteboard. I have copies of the problems rather than trying to do it on the, I don't like writing on the PDF. I'd rather just write on a Word document or the whiteboard. But I'm going to be going over the questions that were on these quizzes that you took in class. I'm also going to post the answers to it. So if you prefer, don't need the video, you just want to check how I did it, you can see that as well. Okay. So anyway, let me just go to a whiteboard and work through question number 1 on both of those. Okay. So question number 1 on one version was x squared minus x minus 30. And so this one did not have a common factor. And so you should have started to unfoil that. In the first spot, you would put an x in each. And then at the end, you want things to multiply to be 30. And you've got a bunch of possibilities, but this one's going to be pretty straightforward because out in front of the x squared is just a 1. So your middle term has to just come from what you pick here. So I know it has to be 5 and 6 if it's going to work, because if I put a 5 in, the inside 2 would be 5x, the outside 2 would be 6x. And I would just need to make the larger one negative so that when I add, I get the negative 1x that I have in the middle. And by putting the larger one negative and the 5 positive, I get the negative I need there. So this would be your answer and you're done. Okay. Question number 1 on the other version was the same problem, just slightly different number, same issue. Let's go ahead and look at that one also. It had a minus 56. So that one was the same basic idea. You're going to do x and x, 7 and 8, and make the 8 negative. And that would be the final answer on it. Okay. Now, different problems were in different locations sometimes. So I'm just going to go down and do number 2 on one version, and then I'll do the problem on the other version that was similar to it. So number 2 on one version had 8p to the third minus 125. Okay, so I look at that one and I say to myself, there's nothing common between 8 and 125. And I see that 3 right there, which makes me think this is going to be a cube problem. So then I go and I think about the cube formula. I'm leaving a little space here on purpose because I'm going to come back and fill something in there. I'm going to write down the formula. Here's what the formula says. Okay. And then I'm going to go in and I'm going to think about, well, what really got cubed to make 8p to the third? And what really got cubed to make 125? So 8 and 125 do not go into the formula. So 8p to the third would have come from taking 2p times itself 3 times. Okay. And then 5 to the third is where the 125 came from. And then, of course, it has a minus there. Okay. So that means everywhere you see an A, you're going to put 2p. Everywhere you see a B, you're putting a 5. So this should be 2p minus 5. This is where sometimes you write it wrong. You think 2p squared, but it's really 2p in parentheses squared plus 2p times 5 plus 5 squared. Then your last step is just to clean up that second, the trinomial part, and write the 2p in parentheses squared as 4p squared. Then this would be 10p, and this would be 25. Double check that you use the right formula and that you have a minus here and a plus here. You know, make sure the details are straight. You all have the basics. It's time for you to get the details, okay? All right, and then the one on the other version was also question number 2. It had 27p to the third plus, let me make sure that I didn't change Let me make sure that it's the one I actually gave you all. Yeah, because I have about 100 versions of these. Yeah, the other one was 27p to the third plus 64. Okay, so it was very similar. 3p would get cubed to make 27p to the third, and then 4 would get cubed. And so that means when we do the formula, it's the plus formula on this one, not the minus formula. 3p goes for the A and 4 goes for the B. The plus formula says it's going to be A plus B, and then A squared minus AB plus B squared. And so everywhere there is an A, I'm putting 3p. Everywhere there is a B, I'm putting a 4. So 3p squared minus 3p times 4 plus 4 squared. And then just like before, you want to clean that up. That's going to be 9p squared minus 12p plus 16. And then don't try to break that down anymore. This will always be too small. It looks like it should break down, but it won't. The formula stopped here because that's as far as that can go. Okay? All right, so that's that one. All right, now let me go to question number 3 on one version, and then we'll look at the related problem on the other. All right, so let's look at number 3. Number 3 was this on one version. Okay, and then that was the same spot for something similar on the other version. And what's going on with these that you should have noticed is that you had perfect squares in the first spot and the last spot. There's nothing common to all 3 terms, so you should start to unfoil. Because that's a perfect square, use 3x times 3x. 16 is a perfect square, use 4 times 4. And then that would be 12x. The outside 2 would be 12x. And if I make them both negative, I would get the negative 24x I would need in the middle. And then the negative times the negative turns out to be 16 positive, like it needs to. Okay. So this one is actually supposed to be a pretty fast one. 5x and 5x, 3 and 3. Trying to make negative 30, so I'm going to make them both negative, so I get a negative 15 and another negative 15, okay? And then that negative times that negative gives me the positive I need at the end, okay? So these can be written just like that, or you could write it as like 3x minus 4 to the second power. All right, number 4 on both were very similar. One version had x to the 4th minus 16, and one version had x to the 4th minus 81. Okay, both of these wind up not being cubes. You know, they don't have a cube formula. There's also nothing common, so you should try unfoiling. Okay, when you do, they both have an x squared in the first spot in each. And then see how the last term on both is a perfect square. So you're going to use 4 and 4 on this other one. You're going to use 9 times 9. And then to make the middle term cancel out, make 1 plus and 1 minus. All right, now a lot of you stopped there. That was a really common mistake. Even my really good factorers sometimes didn't think to go further. But see how that still squares? You should try breaking it down again. But this one cannot break down anymore. X squared minus 4 can. X minus 2, x plus 2. This x squared plus 4, you can't make it be a positive and get rid of the middle term. So you just bring that one down as is, and there would be your final answer. Same deal here. X squared plus 9 is going to be one of the factors because it is prime. It can't break down more. But the minus allows you to break this down into x minus 3, x plus 3. Now, some of you kept like 4s here instead of going down to a 2 and kept 9s here. Okay, and of course that wouldn't work either. So watch those details. It's time for you to pay attention to those. Like I said, you all, especially my Tuesday class, you all did great. So you can really now work on just making it perfect, like all the gory details, okay? All right, the fifth one on one version was different from the fifth one on the other. So number 5 on one version looked like this. Okay. And then the problem kind of related to that on the other version was somewhere. Where was it? Was 10. So 5 on one version was like number 10 on the other version. So let me do those two. They kind of go together. Okay. All right. So what you do, you notice it's kind of big numbers, lots of variables, probably something in common. The y you should notice is common to both. And then see how these are both even? I can pull out a 2y here. What would be left would be a 9x squared, and over here a 25 with a minus. On this one, I'm noticing y is common. And even though these are really big, at least you can tell they're even, right? They end in an even number. So I know I can pull out a 2y from those as well. And I'd have 49x squared minus 16 there. Then you can't stop at that point because like on the other one, see how the other one had a squared and you had to keep going? This is a square. These are perfect squares. So that means you can do it, and it should be pretty quick. You just have to remember to do that step, that third step, factoring again. So 7x, 7x, 4 and 4, 1 negative, 1 positive. Over here, 3x, 3x, 5 times 5, 1 positive, 1 negative. Okay? Oops. And that was number 10 on the other version. All right, so let me keep my bearings about me. All right, so now let's go to number 6 on one version. It looked like this. Okay. And then it corresponded to number 8 on the other version. And what was going on here is you could get these factored without pulling out a common factor. But then most of you who did that didn't finish it up correctly. Like some of you came in, for instance, on this one, and you did things like 2x, and you did like minus 4, and here you did minus 8. And when you checked it, it worked, right? When you FOIL it back out, it gives you that. Problem with it is these have a common factor. So does this. So you would have had to remember at the end to factor out the 2, and then here to factor out a 2, and then to put the 2 and the 2 together and get a 4, and that would be your final answer right there, okay? But the strategy you've been taught is not to do it that way. It's to look for the GCF first, then factor, and then factor again if you need to, okay? That's what you should have in your mind. So always remember to ask about the GCF because it can really save you a lot of time. So really, when you had a problem like number 6, you should notice that 2 goes into everything. In fact, 4 would go into everything, and pull the 4 out. If you do, you would have x squared minus 6x plus 8 left. So what's left is easy to factor because it has a 1 out in front of the squared. So it'll go faster. Okay, I need an x and an x, I need a 4 and a 2, and I need them both negative. Okay, so if you'll remember to take out the GCF, it's really to your advantage because if you can get it to where there's only a 1 in front of the squared, then there's less trial and error. You almost are positive what it's going to take. Instead of using 1 and 8, I knew I would use 4 and 2. Okay, so this earlier approach would work. Some of you had variations of this, like some of you kept the 4 and did 4x minus 8 on one, and then the other one you had x minus 4. That also is true so far. The issue is it's not completely factored because you forgot to go back and pull out the common factor. It's hard to remember to do it at the end, so don't wait till the end. Do it in the beginning, and you'll have better luck. Okay, so like on number 8, see how 5 goes into everything? So pull out the 5. What's left is x squared minus 7x plus 10. Then bring the 5 down and get ready to unfoil. you would use x and x, 5 and 2, and they would both need to be negative so that you would get that negative in the middle, that negative 7x in the middle, and that positive 10 at the end. So if you didn't pull the 5 out in the beginning, you have to remember to do it at the end. Some of you really worked hard and got this thing to break down early, and you had something like this. Okay? All right, you're good so far, but this has something in common, and you would have needed to pull that out. Okay? That wouldn't have been finished. All right, so that was 6. All right, now 7 on one version was 9x squared plus 64. And then the one that corresponded to that, was also number 7. Normally I move those around, which was 4x squared plus 81. Both of those are prime. So a lot of you wrote like 3x, 8, and 8. So I know what you were thinking, but if you really work it out, that's not going to work because you would get a negative there. So that's out. And then if you put them both positive, you get the positive on the 64, but see how this would be 24x and another 24x in the middle, and they wouldn't cancel out. Okay, so you can't make the middle term, the x term, go away and wind up with a positive. So differences of squares are factorable. So we've done that a couple times, like there. Say two terms that are perfect squares, they break down when they have a minus sign. But when they have a plus sign, you keep finding, or should keep finding, that they're prime. So a lot of you left it something like this, either with a plus or you left a minus, but in reality, neither of those work. So it's prime or it's not factorable, okay, is how you should leave it. And look, you need to make it clear. I don't want all possible answers. I want you defending, you deciding what your answer is, and then sticking with it, okay? All right, so let's see now. The next one I want to do is the one on one version that had the y at the end. That threw some of you, but that'll be an easy fix. See, again, you got the gist of it. It's just you got to get the details. On the other version, it was problem 9 that was like that. Okay. All right, and so with these, you might have thought there was something common, but see how x is only common to the first two, y is only common to the last two, and there's no numbers common. So that means since it's a trinomial, you'll try to unfoil. It's just that to get the x squared, you put an x in both slots. To make the y squared happen at the end, you just need a y. Now you got to work on the 35, and you only have a couple possibilities. You have to figure out which of those you're going to use. You're trying to get a middle term that's going to have a number of 2, and nothing's coming from there. So it's got to be the 5 and the 7. So you put a 5 on one, a 7 on the other. Now, what was bothering a lot of you was this. But see, all I got to do is put the x in the beginning one, the y on the ends, and then when I FOIL this back out, the middle term will have one x and one y in it. See that? And that becomes 2xy. Okay, so that's it. All right, and this guy, nothing's common to all 3 terms. So we unfoil. We use x, 6 with a y, 4 with a y. I'm using 6 and 4 because 1 and 24, I can't get a 2 out of that. 2 and 12, can't get a 2. 3 and 8, no way to make a 2 happen. But with 4 and 6, if I put the signs in there correctly, I ought to be able to make that happen. I would need the bigger one positive, and I want them different because I'm trying to get a negative when I multiply. So all of this is based on how you multiply using FOIL. So you always could go back through that whole process, right? Just to check yourself if you wanted to. Okay, really, once you put these in, you know that works. Once you put these in, you know this works. And then you work on getting the signs straight, so you know that and that works. And then the last thing you check is the positive times the negative. So usually I don't refoil the whole thing. I'm just checking the middle term, and then I'm checking to make sure I get the sign right there at the end. Okay. So there we have it. And that's your final answer. Okay. All right, let's look at number 9 on that one. Okay, number 9 on one version was 30y squared minus 25y, and that corresponded to number 6 on the other version, which is 6y squared minus 10y. Okay, those were pretty much the same issue. Okay, so on these, there was a common factor. So a lot of you set up, you did this too early. You should have asked yourself, is there something common? And notice how these are both divisible by 5 and there's a y common. So we can factor out the 5y. Then we'll have 6y left in the first spot and just 5 left at the end. And it's not squared, so that's my final answer. Same concept here. It's just 2 is what's common. And then 3y minus 5 is what's left. And you can't go any further on those. Okay? All right, and then the last one I want to do is the 4-term problem. So that was number 10 on one version. And it looked like most of you were working it out using the whole process. Some of you look like you knew what it should look like at the end, and you were just trying to get it to be that way, but weren't really following a process. This is number 5, corresponds to number 5 on the other version. Okay. I wrote that one wrong. That's an X right there. Okay, let me double check. Got all my signs and everything. Okay, so these were the 2 problems. That should be an X. And I'm just checking that I copied them correctly. Okay, yeah, now they're finally correct. All right, so if you did this one the regular way, you would have looked at how 5w was common. And when you pull out the common 5w, there's a 2x minus y left. Here, see how there's a negative there? You're going to pull out the negative along with the z, which is common. When you do, you're going to have a 2 with the x and the y left. Now, what was hardest was right here. That really, since I pulled the negative out here, then this really needs to be negative so that the negative, when it gets distributed to the second term, the negative times the negative gives you the positive. Okay, and it's good that's what happened because these need to be the same. So you're going to bring that 2x minus y out, and what's left is the 5w minus the z. Okay? All right, let me go ahead and do that one using the box. Some of you tried and were successful. Others were struggling to kind of remember what to do. Okay, so I'm going to put in all the terms. And then this is important. If you get that spot, that's where the GCF for the terms below it, that's where the GCF for these 2 terms should go there. So W was common and so was the 5. You need to be sure to take out the greatest common factor or it's not going to work. Okay? So once you take out the 5W, that multiplied by 2Z would give me the 10WZ. Okay? Then the 5W from above multiplied by a negative y would give me a negative 5WY. Okay? Then I'm going to pull that 2z over to here and multiply it by, see how the 2 and the z I've got coming from the left? So I need the negative x right here. Okay, I said that wrong. No, that's okay. All right. Something's not, I didn't do something correct on one part of this somewhere, and I've got to get straight what I did incorrectly. So let me just double check myself real quick, because these should match. So that should be an X, or it shouldn't be an X. So let me go back. So here I pulled out the 5W and I got a 2X minus a Y. So that's correct. Here there was a Z common. Okay, so I had a 2X, that's right, minus a Y. So that's right. Then I pulled out the 2X minus Y and the 5W minus Z. Okay, so what I'm going to look for is to make sure I didn't put these in incorrectly. No, they look just fine. Make sure I pulled out my common factor of 5W. Okay, minus 5WY. So 5W. Okay, so that'd be negative Y. That'd be 2Z. See how here I'm getting a Z? Oh, I see it. All right, I couldn't figure out why I made a mistake, and I was trying to say these should give you the same answer. Let me show you where my mistake was. When I wrote the problem, see, that's 10WX, and what I wrote in here was 10WZ. You see that? That's the place where I made the mistake. So just like when I was writing it, I got all my letters mixed up. Okay, so let me go back. That's okay. I'm not going to freak out if that happens. I just want to catch my mistake and then fix it. That's what you're going to do. So I want to use the box. It works. It's just I made a typo. This was 10WX. This was negative 5WY. This was negative 2XZ. And this was positive YZ. So I still will pull out the 5W, but then I have an X left, okay, along with the 2. And if I pull out, let me turn that off for a second. Okay, and then if I pull out a 5W, that has to go together with a negative Y to make a negative 5WY. Okay, so just using length times width. What's inside the box is the area. Okay, now if I have a 2X coming from the left right here, then I'm going to have a negative Z on top, because negative Z times that would give me the negative 2XZ. And then this negative times that negative gives me the positive YZ. That's like a built-in check. And my final step would be to write them together, and I would put the 5W minus Z in one parenthesis and the 2X minus Y in the other. Okay? All right. So this one's going to be done in a similar way. All right, so if you did it without the box, you would pull out the 3W, and there'd be 7X minus Y. Over here, what's common was the Z. Pull the negative out along with it, so what's left inside here also is positive 7X. Then notice this would need to be minus Y. So the negative times the negative would give you that positive right there. So now that's common, and you're going to pull that out in front. And what's left is 3W minus Z. And if that last step is where you get stuck or what bothers you, or if you just like it better, feel free to use the box, but I'm going to be way more careful this time. 21WX minus 3WY minus 7XZ and then YZ. So now when I look at it, 3W is common to this and to this spot and this spot. So pull out the greatest common factor, which is 3W. Then you'd have 7 and X left there. And you'd have a negative Y. And then that 7X has to multiply by something to make negative 7XZ. So that must be a Z that's negative. And then that negative Z together with the negative Y would become a positive YZ. So that's like a check. And then my final answer would be what I see on the sides. Okay. All right. So let me stop and post this. I'm also going to scan and post the answer keys for you.